Everyone is terrified to fly. No one would bat an eye if you said your anxiety spiked at the idea of being crammed into a metal tube and blasted through the air thousands of feet above Earth's surface. It's strange, it's unnatural, it's scary, and perhaps that's why flying is the safest mode of regular transportation out there. You are not going to die in a plane crash. Dying in a car crash is one of the most common ways Americans meet their maker. You are more likely to die from a tornado or a bathtub than you are from a plane. Our society takes plane safety extremely seriously, thoroughly investigating malfunctions, heavily scrutinizing manufacturers, and demanding high qualifications from pilots. More manpower than you'll ever know goes into making air travel safe and reliable. Which is why it was so strange when models of the most popular and modern plane in the world started plunging into the ground. This is the No One is Competent podcast, a podcast dedicated to uprooting and showing off the malfeasance found in every corner of our society. And today we are taking a look at planes?
Yeah, we are. In specific, a certain aircraft known as the Boeing 737 MAX.
But Jay, why do we care about planes?
Because I'm a nerd.
I mean, Jay, you can't be that much of a nerd. What, you have a favorite plane?
I do, yeah. Well, I guess it rotates, but if I had to pick one from the top of my head, I would say probably the Saab Vision.
Second favorite plane?
Junkers Ju-88.
Third favorite?
The Kawanishi H-8K.
14th favorite?
Probably go with the McDonnell Douglas MD-80.
Fair enough. We're talking about planes today, ladies and gentlemen. Because my co-host Jay loves planes, I say, Jay got introduced first this time because you're the most important member of this podcast, and don't you ever forget it. I, on the other hand, Azalea, I'm just some weird redneck from Georgia who is here to read shit off of a document, and I totally understand that I will be replaced on this podcast as soon as Jay can find someone with a voice prettier than mine. But before we jump into the bulk of this episode that we have for you, and it is quite a lot of bulk, let me tell you, we should probably offer an apology, because Jay, we have been we've been gone.
Oh yeah,
we have been radio silent, have we not?
Yeah. Turns out that writing a podcast episode, doing my regular job, and making 2 panels for an anime convention was not a great idea in terms of my scheduling.
No, it was not. Basically, the TLDR is that me and Jay both got hit by an obscene amount of both work and private crunch out of nowhere. I, for example, finished the rough draft of my 3rd novel, and then right when I was writing high off that, got struck by the most intense stomach virus I have ever had, which just wrung my body out for multiple days, and then I had to go deal with some stuff down south and some family things, and then, Russia invaded Ukraine, and, that sent me into a depression, doom-scrolling spiral for, hours and days as I argued with terrible takes and dealt with some people just straight disseminating Russian propaganda, which was nice. And then Elden Ring came out, and I've been playing Elden Ring so much that it's giving me possibly permanent nerve damage in my hand. So we've had a strange time, have we not?
Yeah, I can't think of many times we've recorded an episode and, wondered whether the world would be with one fewer sovereign nation by the time we actually publish this thing.
Yeah, and we're not going to talk about the situation in Ukraine right now because when you listen to this podcast, the situation in the war will no doubtedly be different. But to be very, very clear, I feel somewhat obligated to say this, but this is a completely unjust and insane invasion, mostly predicated on the ego of one man, Vladimir Putin. Ukraine is a sovereign nation with its own language and culture that goes back hundreds of years, possibly longer, and this is a fucking obscene violation of human rights and every decency that every culture on Earth has ever come up with. And we stand with the Ukrainian people. If anyone in Ukraine is for some reason listening to this, or anyone from there, know that my prayers are with you, and I hope that God protects you and everyone you love. It is a really shitty situation, even by the hellish standards that most people live under every day.
Yeah.
But we are here to distract from the depravity of the world by being entertaining and cool. Jay, are you ready to make some fucking content?
I suppose I'm ready as I'll ever be.
Let's make some fucking content! So, today we are talking about planes. So first we have to, explain planes. When we do warfare episodes or big political episodes, we have to give history or political context what's going on. Today we're doing a flying episode, so we have to give flying context to what's going on. And we got to get into probably more science than we have since our nuclear warheads episodes. This is going to be fun.
Yeah, should be interesting to see how it goes.
How does mankind put a giant metal tube that weighs hundreds of tons into the air?
Using a little thing called lift. Yeah, there are a couple other forces involved, but, lift turns out to be a very useful force. So I guess to keep things simple, then, starting from the beginning, there are four forces acting upon any airplane in flight. Those forces are thrust, drag, lift, and weight. Thrust, which is typically generated by the engine or motor, is what pushes the airplane forward. And as the airplane moves through the air, two forces relating to fluid dynamics come into play. Just as a note, we call it fluid dynamics, even though air is a gas, not a liquid. Airflow is considered a part of, fluid dynamics.
Most gases and liquids count as fluids.
Yeah, exactly.
A fluid is anything that takes the shape of the container that you put it in.
Yes.
I think. From
something like that.
Chemistry class in 8th grade. Something like that, yeah.
As the airplane's going through the air, it encounters something called drag. That's air resistance, and that goes in the opposite of thrust. It imparts a rearwards force on the plane parallel to its movement. Lift, on the other hand, acts perpendicular to the movement of the plane through the air, and providing an upwards force that allows for flight. And finally, of course, weight acts opposite to lift, pulling the airplane down.
Yeah, so if you close your eyes and you imagine a plane flying from right to left, the thrust is going, imagine kind of an arrow rightwards. The drag is then going leftwards against the thrust. The lift is going up, and then the weight is going down.
Exactly, yeah. Now, airplanes use the air flowing over and underneath their wings to generate this lift. In order for an aircraft to fly, the lift generated by its wings must be enough to overcome the weight of the aircraft. Now, the exact physics behind how wings work is surprisingly complicated and commonly misunderstood. You might have heard a simple explanation in grade school about how lift works, probably mentioned Bernoulli sometime. That explanation is kind of incorrect.
I mean, the vast majority of things you learn in school are either drastic inaccuracies, drastic simplifications, or in the case of most economics and history classes, just straight propaganda.
Yeah. Now, to keep things simple, as a wing moves forward through air, its shape, which is known as an aerofoil, generates pressure differentials in the air flowing over and underneath it, and deflects air downwards past its trailing edge. The act of deflecting air downwards and the upward suction created by the area of low pressure above the wing combine to generate lift.
Yeah, so it's kind of like that low pressure under the wings. It's like having like floaties on your arms while you're in the pool. Like it creates a pocket of buoyancy which pushes it up.
Yeah, it's higher pressure underneath the wings and lower pressure above the wings. So
it's the same. It's a very similar idea to if you ever stick your hand out of a moving car, and you put all your fingers together and you sort of you feel an upwards pressure on your palm.
It's exactly the same as that, more or less. You can make an aerofoil with your hand, just sticking it out of the car. Now, aerofoils are only effective when used at certain angles relative to the oncoming airflow. The angle of an aerofoil relative to the airflow is something known as the angle of attack. This is a term we'll be mentioning quite a lot in this episode. Now, just as a brief note, the angle of attack is relative to the airflow, not the ground. You might see an airplane flying 45 degrees, and just continuing to climb. The angle of attack in that instance is not 45 degrees. It can be as low as 0. If an airplane is pointed 45 degrees upwards but is not climbing, then the angle of attack is about 45 degrees.
So it's about whether or not the plane is gaining elevation.
Gaining or losing, yeah. But yeah, the angle of attack, again, it's relative to the oncoming airflow, essentially the wind hitting the wings, not the ground.
But that's not necessarily the angle of the nose compared to the ground.
Exactly, yeah.
But they're often similar?
They're often, it really depends, For example, if you point an aircraft just straight 90 degrees upwards, say you're a fighter pilot, and you point your aircraft 90 degrees in the air, and jam the throttle, and just fly straight up, the angle of attack for the wings is not 90 degrees, because the air hitting the wings is coming straight down, parallel to the wings. The wings are oriented vertically, the air is hitting them vertically. So even though the airplane in that instance is pointed straight upwards, the angle of attack is not 90 degrees. On the other hand, if the aircraft is, say, coming in for a landing, and you can actually watch videos of airplanes landing, oftentimes the nose will be pointed upwards, but the airplane will actually be descending. In this case, again, the angle of attack versus the angle relative to the ground are two different values.
Okay, so I'm starting to get it. So the angle of attack refers to that pocket underneath the wing of lift.
It's like the angle of attack is simply the angle relative. No, it's simply the angle relative to the oncoming airflow.
But it affects how much air gets under that pocket.
Yes.
Okay, yeah. So that's that. All right, it's starting to make sense in my brain now. Hopefully everything we just said have made it make sense in the audience's brains too. If not,
we'll have some pictures on the
we'll have
YouTube
some pictures
version.
on the YouTube, and I don't know, man, start reading Wikipedia. It's Learning is hard.
Think of it like a vacuum cleaner. The vacuum is inside of the vacuum, and it pulls stuff up into it. Now, the angle of attack is a very important thing for a pilot to monitor because of a certain thing called stalling. Stalling is essentially when the wing stops generating lift, and that is a very dangerous thing. If you look up any airplane crash, there's a very good chance that somewhere in the description of the crash, you will hear the word stall. So what happens?
Is this related to the phrase, like, engine stalling? Is that similar?
It's probably from a similar etymology, but the processes are very different.
So this does not have to do necessarily with what the engine of the plane is doing. This has to do with the physics of the plane moving through the air.
Yeah, and the physics involved is if the pilot pitches the nose of the plane too far upwards, but it doesn't actually climb, it doesn't have enough airspeed, it doesn't have enough thrust to climb up, the angle of attack will end up exceeding the degree at which the airfoil can generate lift. The air flowing over the wing will thus separate from the top of it, and no lift will be generated. To go back to your analogy of sticking your hand out of a car, when you do that and when your hand's level, you feel a lot of wind rushing around your hand. If you angle it slightly upwards, you feel that force lifting your hand up. But if you hold your palm perfectly flat against the wind, there's no force lifting it up anymore. It's just pushing backwards on it.
Sure.
Now, one can imagine here a pilot attempting to combat a scenario in which his airplane is no longer generating thrust due to an engine failure, let's say. In order to remain in level flight, he would resort to pitching upwards to increase the lift, because normally increasing the angle of attack does increase your lift. As the airplane slows, he needs more and more pitch to remain in level flight. At a certain point, however, the angle of attack becomes too great and the wing stops generating any lift. That's known as a stall.
So the higher you get, the greater your angle of attack, the more lift you get, but there's an inflection point where it reverses.
Yeah, it's like playing blackjack. You're trying to get close to 21, but the minute you go over, you're done. Now, contrary to popular belief, angle of attack, not airspeed, is what determines a stall, though low airspeed is a common factor behind a high angle of attack. Now, stalling is something familiar to all pilots. Indeed, experiencing and recovering from stalls is a part of basic pilot training. Most aircraft can recover from a stall by pitching down and increasing thrust, if possible, but stalls can still be deadly. If the pilot does not recover properly from the stall, or if there is not enough space, usually that means altitude above the ground for recovery, a stall can be fatal. Stalls are behind a large percentage of all airplane crashes, so they're something that, again, is taken very seriously.
And just to add, because I think I'm starting to get my mind around the physics here, the reason thrust is important is because you need to be moving forward to force that air under the wing that generates your lift.
If you have no thrust,
it's harder to do that.
Yeah. If you lose your engines, you're basically a glider, and an airplane will be able to glide for a certain amount, but not forever.
Not forever. Okay, that is the physics of flying. Most of that is over now. Re-listen to that section if you have to. The scary time is over. Well, the very, very scary time will return at the end of the podcast, but you will not have to be scared of physics. Flight is controlled by physics, but this is not a podcast about flight. This is a podcast about flying, and flying is controlled by economics. Capitalism. Airliners are airplanes primarily designed for carrying passengers on commercial flights. The jet-powered airliner is the backbone of the modern long-distance travel networks. If you've flown on a plane, you've probably flown on a jet airplane. In fact, jet airplane is just kind of merged with airplane in at least my head of words.
Yeah.
To most of the hundreds of millions of people who travel on airliner each year, all airliners basically look the same. They're visually interchangeable white tubes. Maybe they've got a different color on the fin and a different brand logo on the side. But to an untrained eye, if you're just like in the airport looking out the big windows at the planes sort of taxiing by, they all look more or less the same. At least they do to me. To Jay, they probably look all completely differently. But they are using a layout that has been sort of crafted over the years to be the most efficient and optimal for their role of transporting people across the planet Earth. That's why they all look very, very similar. And specifically, they're all kind of modeled after this style, pioneered by the main character of today's story, the company Boeing.
Indeed. In December 1957, a 4-engine jet-powered airliner took to the skies for its first ever flight. This airplane was the Boeing 707, designed and manufactured by the then 40-year-old Washington State-based company, Boeing Corporation. Now, the 707 was not the first jet airliner. The first was the British to have one, Comet. But the 707 was the first to popularize the basic layout that is still used by the majority of airliners to this day. A long, narrow, cylindrical fuselage with podded engines hung underneath narrow, mildly swept wings.
And the fuselage is like the whole of the plane.
Exactly.
It's the tube.
Yep. Prior to the 707, Boeing was actually a minor player in the world of passenger aviation. The field at the time was dominated by Douglas, Lockheed, and a variety of foreign companies. Almost overnight, the 707 transformed Boeing into the largest airliner manufacturer in the world, a title which they would retain for the rest of the 20th century.
And this is just because, jet-powered airliners can, carry more people, they're more efficient.
Yeah, more efficient, more people, faster, more reliable even. I mean, a jet engine's more reliable than the big, 20-cylinder behemoth piston engines that they used previously, because there are far fewer moving parts. While the basic shape of these airliners has not changed in the 65 years since the 707 took flight, it would be a mistake to think that all modern airliners are basically identical. As anyone can observe by visiting an airport that handles both domestic and international flights, two airliners with similar designs can vary greatly in terms of their actual dimensions. Now, back in 1957, the airlines had relatively few options to choose from if they wanted a jet. Nowadays, the offerings are much more varied, ranging from the 72-seat Embraer E170 to the 300-plus seat Boeing 777s.
Hundreds of thousands of people fly every single day, and so a lot of math goes into moving those people around as economically as possible. You want as many bodies through the air with as low a cost. And businessmen, engineers, and accountants over at the airline spend a lot of time crunching these numbers to determine what size of airplane they need for their business. Now, remember, the airlines, that's Delta, that's Spirit, those are corporations. Now, they might employ engineers and smart people, but they're not the manufacturer. They're not building the planes. They own the planes, as we'll go into. They have some input into what the planes look like and do, and I'm sure Delta, for example, and I just think of Delta because I fly out of Atlanta all the time, and
it's a big Delta hub.
At Boeing, they talk a lot about what the planes are going to look like and whatnot, but the airlines run the planes, the manufacturers build the planes. That's the separation of church and state, shall we say.
It's actually a very old law going back to the early 20th century in the U.S. saying that the manufacturers cannot own their own airlines.
Oh yeah, because we used to care about horizontal integration and monopolies and shit.
Yeah.
Or maybe that's vertical integration. Who gives a shit? Anyway, the engineers over at Boeing figure out how to make the planes really good, but the number crunchers over at, say, Delta or Spirit or Southwest say what plane they want Boeing to make for them. And they've generally figured out over the years that the most efficient thing to do is to fly one 300-seat plane rather than three 100-seat ones. And this has a lot to do with fuel, which is one of the biggest costs when operating an airline. And over the decades, they also figured out a sweet spot was that you would have a twin-engine airplane seating roughly 150 passengers. I've probably been on one of these a dozen times. If you've flown domestically across the U.S., this is probably what you got on. As a result of these economics, two airliners that fall within this sweet spot and are really good at making these kinds of planes have come to lead the world of commercial aviation. These airliners, or to be more specific, airliner families, are the Boeing 737 and the Airbus A320. With over 10,000 units manufactured apiece, these two are the number 1 and 2 most produced airliners in the world. It's really interesting to me, Jay, this kind of goes back to a thing we talked about in our nuclear warheads episode, that we often think of technology as this sort of incrementally, every year technology gets, say, 25% better or 15% better. It's just sort of a straight line all the way up. But that's completely a misconception, right? In the 50s, this new technology of the jet engine was invented, and you see it's like a massive exponential spike in technology. But then every year since, they're way better. Sure, they're way more efficient. That maybe they use some different materials and they made a few tweaks, but fundamentally, it's a slow climb after that, because it really looks like more or less the same thing. The engineers who probably worked on those jet engines in the 50s could look at a jet airliner today and they might be surprised a little bit, but they could fundamentally understand what's going on.
Yeah, you think between 1903 and the 1950s, you went from the Wright brothers being barely able to fly the length of a football field to jet-powered airliners crossing the Atlantic Ocean. Between the 1950s and today, we've gone from jet-powered airliners crossing the Atlantic Ocean to them doing the same thing, just using a bit less gas. Well, a lot less gas, to be fair.
It's how inspiring. But this is why in the 70s people thought that in 2022 we'd be able to book a trip to Mars.
Yeah. Yes, it was the same sort of mindset. Yeah.
But it turns out the law of diminishing returns is one of the crueler mistresses on Earth. And now we're going to pivot to basically telling the story of how Boeing and Airbus came to be the two big boys on the block. This is a American-centric podcast because we are both haughty, jingoistic, ambitious, arrogant, and badass son of bitches Americans. So we're going to talk about Boeing, who is also, coincidentally, the people who seriously fucked up in this podcast. I don't know where I'm going with this. Jay, tell the story about how Boeing becomes the king of the skies.
Yeah. Well, in specific, we'll be talking about the Boeing 737. Now, the 737 was designed by Boeing back in the 1960s, and their original intent was simply to produce a smaller, shorter-range counterpart to the then most popular airliner, which was the triple-engine Boeing 727. The 737 would supplement the 727 on shorter and less popular routes, and challenge the smaller regional jets, which was a sector that had been previously ignored by Boeing.
Question. Why is it called? Is there any significance to the numbers 737, or do they just like 737.
They like sevens, and the number in between has gone up incrementally. So like the 737 came after the 727. The 707 was before both of them. The original 17, I believe, was like a design that never actually made it out of the factory. And you have the 747, which is quite famous in its own right, coming afterwards. But yeah, Boeing at the time had built a reputation for superb design and engineering. The executives knew what planes would do well with their customers, those being the airlines, and the engineers knew how to make them. The 737 in many ways would confirm this reputation. The eventual design of the 737 that Boeing's engineers came up with was one that suited their target market well. The 737 utilized the same fuselage as the 727, which in turn was based on the 707 from the 50s, but it was shortened as the seat count was lower than that of the 727. This would seat between 85 and 115 versus 130 to 155 people. As the plane was smaller, the designers could eliminate one of the engines, which resulted in a twin-engine plane that was also more efficient than its triple-engine counterpart.
And this was because this thing is, again, being designed for shorter flights to more... This is like a plane that was designed to take you from, I don't know, Denver to Dubuque rather than Manhattan to LA.
Yes, exactly. Now, these engines were relocated from the tail to beneath the wings, where they would be easier to access for maintenance crews. Finally, the landing gear of the plane was shortened during the design process. The shorter landing gear meant that the 737 sat low to the ground. As the 737 was meant to fly out of smaller regional airports, many of which at the time lacked air bridges, those things which you usually use to get on the airplane, they connect to the airport. And
I have actually, other than a small prop plane I once flew in to go above the Arctic Circle, I have never boarded a plane without using an air bridge, because I've always flown out of the Atlanta airport, which is huge.
Back in the 60s, and even in some places today, you would board airplanes by going out on the tarmac and climbing up a set of stairs. But yeah, so a lot of the smaller regional airports didn't have the air bridges, and they often didn't even have taller air stairs or cargo lifts, to get cargo into the belly of the plane, which meant that the low height of the 737 would make it easier to load and unload passengers and cargo, as well as perform maintenance on the jet.
Keep this idea of the 737s being squat and low on the ground in your head, because it will be very, very important later.
Very, yes.
But at first, everything went really well. The 737 first took flight in 1967, and just like the 707 a decade prior, it soon proved to be a commercial success as orders poured in for the new plane from around the world. Now, as we noted earlier, the basic shape of commercial airliners has not changed over 60 years. But that doesn't mean that the engineers have just been getting drunk all day. They have changed what's under the skin of the plane. Perhaps the biggest area of technological advancement in commercial aviation since the first flight of the 707 has been that of engine efficiency. Remember when I said that fuel was one of the most expensive parts to running an airline? New advances in material science and design processes allow for more efficient engines to be designed and built. This means more flying for less fuel, and newer engines could also generate more power and do so quite reliably. The furthering of jet engine technology is something that's been ongoing since the 50s and continues to this day. And this is where I have put a bugbear in, because I have recently learned that planes haven't gotten faster since my grandparents got married, and That pisses me off.
Yeah, in fact, while they fly about the same cruise speed, at least in on paper, a lot of airliners now will actually fly them a little bit slower than they used to back in like the 60s or 70s. Not by much, but a little bit slower.
This should be a moral outrage. Like, this
So
should
fuel efficiency.
insult the pride of every American. This is one of them, like... You're telling me the country of the Ford F-150 is running the plane slower than during the Nixon administration?
Yeah. I mean, in fairness, a single transatlantic flight will burn more fuel than an entire season of Formula One racing. These things use a lot of fuel, so you can see why efficiency is prioritized so much.
And at some points, people just figured out that the most economical thing is to slow
that's
down
the other thing. We would have, supersonic transatlantic air travel. We actually did for a while with Concorde, if people were willing to pay for the ticket prices. But there's just not enough of a market for that. Most people at the end of the day will fly for 8 hours for a quarter, a fifth of the price and doing the same trip for 4 hours. The advances in jet technology are made visible in two main ways. The first is the decline of triple and four-engine aircraft, as two became sufficient for most flights. And the second is the size of the engines themselves. Early airliners used what were called low-bypass turbofan engines, but advances in engine design have led to the rise of more efficient high-bypass engines, which feature significantly larger fan blades. To just give some numbers, the JT3D turbofan engines used on the Boeing 707s in the 1950s had a fan diameter of about 53 inches, or 4.4 feet. The fans on the GE90 engines on the modern 777 have a diameter of 128 inches, or 10.67 feet. In other words, they're over twice the size.
Yeah, so for the stupid people amongst us, the big cylinder thing engines under the wing that make the plane go, those have gotten bigger.
Yes, much bigger.
Way bigger.
Now, since the fan diameter determines the overall width and height of the engine, jet engines, those big cylinders, have become wider and wider. Noting the advances in jet engine technology and faced with competition such as McDonnell Douglas's MD-80, Boeing decided to update the 737 for the 1980s, and central to these upgrades was a switch to the larger, more powerful, and more efficient engines.
Unfortunately for Boeing, swapping out the narrow old JT-8D engines for new CFM56s was not an easy task. By the way, try saying JT-8D engines 5 times fast. One of the selling points for the 737 was its low height when on the ground. Remember, it's low, it's squat. We've already mentioned that. It's going to be very important. Keep remembering it. This low ground clearance is now a problem. There's not enough clearance to accommodate the new, wider engines in place of the old ones. But engineers are pretty smart, and eventually a solution was reached. The engines would be moved forward of the wing and upwards. Even with this change, the designers would be forced to use oblong nacelles. That's the casing in which the engine's in, squashed on the bottom rather than the round ones more commonly used, in order to provide a safe level of the ground clearance of the engines. Obviously, you don't want your engine to be so close to the ground because you don't want to accidentally run it into the tarmac and turn the entire plane into a giant smoking tangle of burning metal.
That would not be a good idea.
This new generation of 737s, which we now call the 737 Classic, would take flight in 1984 and proved to be more successful than the original series that preceded. The more powerful engines also meant that the 737 could be enlarged. effectively replacing the 727 in Boeing's lineup and becoming the dominant narrow-body airliner around the world. Remember, these things were meant for short regional flights, but now, because engines are more efficient, a two-engine plane can do pretty much everything commercially we want to do.
Yeah. Yeah, like now you weren't just taking these things from New York to Boston. You could take these almost anywhere across the US. It would only be for international travel that you need something bigger.
But then, speaking of international, across the east, a new challenger to Boeing's dominance would arise.
Yes, and that, of course, is a company which some of you might be familiar with, Airbus. Now, the 1980s can be seen as the high watermark for the 737, with the classic easily pulling ahead of all of its rivals. Across the Atlantic, however, work was underway on a plane that would challenge it for domination in the narrow-body market. This might seem like an obvious thing to say, but developing and manufacturing airliners is hard. These airplanes are vehicles that fly through the air at 80% of the speed of sound, that's over 600 miles per hour, carrying hundreds of passengers, and they do so multiple times per day, day in and day out. They have to be efficient, reliable, safe, and capable. The industry is thus one that is incredibly hard to enter, and even harder to make money in.
Yeah, just to think about it for a moment, there's only so many people on the planet smart enough to make these things. So you have to hire those people. And obviously you want to hire the ones that are smarter than your competition. They don't come cheap. Then there's building the factories and test and design space to build these things, which obviously have to be huge because planes are huge. And this is all before talking about international regulations and getting all of the very expensive materials and it's a fucking nightmare.
Yeah. Boeing throughout the 50s and through to the 80s did have multiple competitors from America and abroad. There were Convair and Lockheed in the United States, and Dassault in France, and Vickers from Britain. One by one, these companies exited the industry, unable to compete or even turn a profit making airliners.
By the early 80s, Boeing's only significant established competitor was McDonnell Douglas, another American company. They were in a very clear second place in the industry. Realizing that smaller companies had no hope in competing with either of the American giants, Europe's aviation industry had come to an agreement in the late 60s to pool their resources and create a new European company, Airbus. Airbus's first plane, so Airbus is kind of like the European Union of airliners. Airbus's first plane, the A300, had proved to be a modest success in the 1970s, and now the company was working on a new plane, the A320. Is it A320 or A320?
A320.
Which would directly challenge the 737. The Airbus A320 would first take flight in 1987, and it looked very similar to the 737, especially in size, performance capacity, and it even used the same engines that the 737 was using. It was, however, a much newer aircraft. Remember, 737 Classic is an improvement on a design that had been being used for decades. This is like a brand new built plane for the task. And it utilized the latest advances in technology of the time, with advanced features such as digital fly-by-wire controls, computerized flight envelope projections, and a sophisticated autopilot. Being a European plane, sections of the aircraft were built in Germany, Italy, Spain. They were built in Spain.
Yes. You good?
No. Sections of the aircraft were built in Germany, Italy, Spain, and the United Kingdom, while final assembly occurred in France. Okay, Jay, back to you.
Yeah. After an initially rocky start, you might have seen a video of one of these things crash into a forest after taking off. That was like one of the first ever A320 demonstration flights. So yeah, not great PR. It turns out that was due to pilot error, not the airplane itself. But yeah, the A320 proved to be an excellent airplane. It was easier to fly and had a slim performance advantage over the 737. The 737 was still competitive, and it led the A320 in sales, but by the mid-90s the gap was shrinking between the two as the A320 threatened to overtake the 737 as the most popular airliner on the market.
And Boeing can't have that.
No, they certainly cannot. The rise of the A320 forced a response from Boeing. Boeing had been the top dog in the industry since the 50s, and arguably never before had their position been threatened in such a significant manner. Their response was the 737 Next Generation, which first took flight in 1997. I suppose they were Star Trek fans. With a redesigned
Beat me to
wing,
the joke.
With a redesigned wing, slightly more powerful engines, and updated avionics, the 737 NG closed the gap to the A320 on paper and re-established its lead in terms of sales. The two would continue to trade blows on more or less equal footing throughout the 2000s, with the A320 retaking the lead in sales, but not firmly pulling ahead of its American rival. Both aircraft, at the end of the day, were capable and competitive with each other.
Let's be honest, Jay. At this point in the late 90s, early 2000s, there is not a single engineer making planes who is not an avid Star Trek watcher and isn't getting into drunken, screaming arguments with their friends over whether or not TNG or DS9 is better.
Yeah. I guess you have the one weirdo who's like a Voyager fan.
Voyager has like 3 good seasons.
I should say, like, yeah, it's okay to be a Voyager fan, but like to think it's better than the other two, like
we do
those
not
are the real
discriminate against Voyager fans on this podcast. Enterprise fans, on the other hand, will be shot on sight. Anyway, by the 2000s, the Boeing 737 had gone through 3 major generations. We've already talked about the original, then we talked about the classic, and now we're on the next generation. But now it's time for the A320 to have a major update. That update would come in the form of the A320neo, New Engine Option, which was announced in 2010. The A3neo was a major shock to Boeing and aviation in general. Most had assumed that the A320 was still years away from a major update, as Airbus was still coping with the financial pressure under their ambitious A380 program. Okay, Jay, this what the fuck is that?
The A380 is the largest airliner in the world in commercial service. It's a double-decker, massive aircraft.
So because they were making this huge international aircraft, they didn't think they would have the time to also update their shorter range one.
Yeah, the A380 had been under development for decades and actually was coming into production in the 2000s and actually ended up being a bit of a failure. The economics of the market had shifted away from really big aircraft towards small to mid-size aircraft. So, yeah, Airbus was like in the red due to the A380, and people thought like that meant that they wouldn't be able to do anything new for quite some time.
But the point for people to remember is that the A320neo is really good and it kind of takes Boeing off guard. The most significant area of improvement in it was its engines. The A320neo would come with a choice of 2 larger, hyper-efficient engines, the CFM LEAP and Pratt & Whitney PW1000G. These engines would give the A320neo a clear advantage in both efficiency and range over the previous A320 and especially over the 737 next generation.
Yeah. Airbus's timing turned out to be superb. The aviation industry was booming, with new low-cost airlines springing up seemingly every week in China, India, Europe, and the Middle East.
Is this where Fly Emirates, the brand seemingly on the front of every Latin American soccer team, starts like taking over international flight?
Yeah, like Emirates and Etihad like start becoming really big, and Qatar become really big during this time. And you also have a ton of like low cost airlines all over the place.
And they need new planes, and Airbus happens to have just come up with a new shiny toy.
Yeah. And orders poured in for the A320neo before it even took flight. The most significant of these orders, for our story at least, was an order for 130 A320neos on top of a further 130 current generation A320s that was placed by American Airlines in 2011. American Airlines had up to that point been a sole customer of American-made jets, buying almost exclusively from Boeing and McDonnell Douglas, which Boeing had acquired in 1997. Now they were placing an order for 260 Airbus jets, and it looked like other American-based airlines would follow suit.
And this 260 order, this is like tens of millions of dollars, hundreds of millions of dollars.
Hundreds, this is
hundreds
a really
of
big
millions
order.
of dollars. That is going directly to Boeing's competitor on its home soil.
This is a big chunk from Boeing, because American at that point, again, only bought American jets. And now they were buying a ton of Airbuses. The A320neo and the orders it was getting, particularly the American Airlines order, forced Boeing once more to respond or risk losing their dominant position in the industry. The A320 was already pulling ahead of the 737 in sales, and if the Neo came out without a Boeing rival, Boeing could virtually kiss any new 737 orders goodbye. This fear of losing market share would lead to the creation of the latest and most likely final iteration of the venerable 737, that of course being the topic of today's episode. It only took us about an hour to get here, the 737 MAX.
And as we'll discuss, the 737 MAX, you're not a topic of a no one is competent episode without both a illustrious history and a brutal. I was going to say fall, but that that seems even too on the nose for me in this case. So actually, let's not. Boeing needs to design this new plane, the 737 MAX, to compete. But by 2011, the base 737 design is 44 years old. It had been updated heavily, but its aerodynamics still reflected its 1960s origin. One can say it had the roots even in the 50s, as the nose and the fuselage of 737 were taken from the 727, which was then taken from the 707. And even with the updates, it was an old airframe that was just barely able to keep up with the A320, mostly just on Boeing's reputation and place in the industry. Boeing, of course, knew how old the 737 was, and they had entered the 2010s with two main options in mind. They could either keep updating and re-engineering the 737, or finally develop a clean sheet replacement for its jet and ending the production of the 737. And if they had gone with that later choice, they could have gotten a leg up on the Airbus, giving them an advantage similar to the one that the A320 held of the 737. That choice, however, was very, very expensive, and Boeing's executives feared a repeat of the cost overruns and delays that occurred earlier with their expensive 787 program. This meant they went with the first choice, re-engining the 737 again. It's fine. It's going to be cheap. It's going to be quick. But listen, we did the classic. We did the next generation. We're doing it again. It'll be fine. And when they start hearing rumors that American Airlines will be placing their massive Airbus order, that kind of pushed them even more in the direction of the fast, cheap option to get a new engine out for the 737, because they don't need to be able to compete in a few years. They would need to be able to compete now.
The development of the 737 MAX began in 2011. Its development would be quick, as Boeing execs went about selling the plane to airlines with the idea that would enter service not long after its competitor. Boeing couldn't let Airbus dominate the market while the MAX was stuck in development. Central to the MAX development were the new engines. The MAX would use the same CFM LEAP engines as the A320neo in order to be competitive with it. Boeing's engineers, however, now faced the same challenge in 2011 that their counterparts had faced back in the early 80s when designing the classic: how to fit an even larger engine onto an airplane that was clearly not designed for such things. The original engines of the, going way back to the 60s, had a fan diameter of roughly 39 inches. The Classic's engines had upped that diameter to 60 inches, and that was already a tight fit. Now the MAX would have an engine with a fan diameter of 69 inches.
Too wide!
Oh, I thought you were just going to say nice.
Jay, how many podcasts have you recorded with me now?
I don't even remember which episode this is, actually.
16.
A fair amount. 16, yeah.
How long have you known me? How long have we been close friends?
A few years now, at least.
And you think that the skill and prowess of my comedic vigor, force, and magnificence is restricted to just saying nice after 69?
Yes.
You really think that little of me?
Yeah.
Some friend. Fucking
Now,
jackass.
At this point, you might just be asking, why didn't they just make the landing gear longer? That sounds easy on paper, but it is pretty hard, because basically the landing gear and the landing gear housing are a vital part of the aircraft's wing box. The wing box is the term for where the wings join up with the fuselage, and redesigning that part of the airplane would be very expensive and time-consuming. At that point, you might as well just design a new airplane.
So you would have to build the plane every time you iterate and make a new design. You might have to do that several times, right? Models can only get to so far, and that obviously is really expensive.
Yeah, and when you're talking about things going at 600 miles per hour, slight changes to their overall shape, as we'll see later, can have a big impact on the aerodynamics. So things which might seem like a simple change can actually be quite complicated. Aerodynamics can work in mysterious ways. Now, the 737's engine nacelles, which were already had their mass forward of the wings, would have to be moved even further upwards to accommodate the new fan diameter. This was not a big problem from a structural standpoint. It's actually the norm for airline engines to be mounted slightly forwards of the wings anyways these days, but it would cause some problems further down the line.
Fun fact, until I read the script for this episode, I just assumed that the word nacelle was something that Star Trek made up. The new position and excessive size of these nacelles messed with the 737's aerodynamics. In 2012, wind tunnel testing showed Boeing that the excessive size of the nacelles was messing with the 737's aerodynamics. The engine cowling, as it turns out, was generating its own lift. Jay, what is the engine cowling, real quick?
That's just, the bit of a metal that's actually housing the whole front of the engine.
And this meant at certain speeds, the center of lift would shift forward enough, and the center of gravity would cause the 737 to pitch up excessively, putting the plane at a risk of stalling. So basically, this plane was good, but it had this nasty habit of suddenly shoving itself upwards, which could make it, stall out and drop like a stone.
Yeah, which is a bit of a concern.
Airliners are usually designed to be fundamentally stable. If loaded and trimmed correctly, they should naturally tend towards steady, level flight, even without any control inputs. And their behavior when approaching a stall should be predictable enough for pilots to notice the oncoming signs. Basically, these things are so steady in the air. Like, for instance, I often fly from Atlanta to Bozeman, and this means that, the pilot does a lot of work when he or she takes off, and they do a lot of work when they gotta land the thing. But the vast majority of that flight of 4 hours is just basically a glide path, I assume.
Yeah,
So
it means like even if they turned the autopilot off and didn't touch the control column, as long as the airplane's trimmed correctly, it'll just keep on flying straight, as long as the weather isn't too bad.
and it has fuel.
Yeah.
So even when there's a problem with these planes, it tends to sort of develop slowly over time, and these pilots, who are again very well trained, have the time to figure out what's going and to make necessary adjustments. But during flight testing, it's discovered that the MAX is not behaving like this. It's not behaving like the previous 737s. When approaching a stall during a maneuver called a wind-up turn, this maneuver is rarely used, but it is a part of an aircraft certification testing, instead of behaving smoothly, the plane was prone to pitching upwards in a very sudden manner. And this unstable behavior wouldn't necessarily be fatal, but it represented a significant enough change to the 737's flight characteristics that pilots certified on the 737 Next Gen would have to go through advanced simulator training to recertify on the MAX, a costly expense for airliners. And again, this is at a time where Boeing is in a very tense bidding war. Like, if they make their thing too expensive, their competition is already, the airliners are already snapping up their competition. They can't make it too expensive. And Boeing had already been banking on the idea that pilots were not going to need any more training apart from just a few hours tutorials on an iPad for the MAX. They were planning on selling the MAX with this idea that, hey, your pilots already know how to handle a 737, and this is basically the same thing. So this is a serious problem for Boeing because it's kind of throwing a wrench in their entire plans of putting out basically the same plane and not needing pilots to do any more training on it.
Yeah. Yeah, like, just to reemphasize, like, when you think simulator, you might think, well, why is that expensive? These really advanced, realistic simulators, they're expensive. There are not that many of them, and it costs the airlines money to rent, basically. And it means that you're taking pilots out of regular revenue service. Again, like, would this be the end of the world for an airliner? No, it wouldn't. But it's something which Boeing didn't want to do. They wanted the MAX to be the best deal for the airlines, so they would buy it.
And from the airline's perspective, again, this is a time where they are facing increased competition all over the world, right? And so they need to keep their margins really tight. Yeah. We've been talking about engineering throughout this entire podcast, but at every turn, that engineering has been affected by the financial constraints on the engineers and the economics and capitalistic influence on this whole process. This is why it's kind of silly to teach engineering without talking about those kind of things, in my opinion.
Yeah. So rather than fix this problem aerodynamically, if possible, or reconsider the whole idea of re-engineering the 737 again, Boeing decided on a quick and easy measure. That would be a bit of software known as MCAS, the Maneuvering Characteristics Augmentation System.
Question before we go into the Maneuvering Characteristics Augmentation System. I assume that this problem of the airplane pitching upwards suddenly was discovered like pretty late into the MAX's development, so it was even harder for them to readjust. That's usually how this kind of thing happens.
Yeah, like they had hints early on with that wind tunnel testing, but the severity wouldn't really be realized until later on. So
okay,
MCAS,
tell me about the Maneuvering Characteristics Augmentation System. For some reason, I kind of really like saying Maneuvering Characteristics Augmentation System.
I'll stick with calling it MCAS. MCAS is a program built into the 737 MAX flight control computer. Its operation is pretty simple. When the computer receives data from the aircraft's angle of attack sensor that the aircraft is at risk of a stall due to the changed aerodynamics of the 737 MAX, it automatically trims the stabilizer to pitch the aircraft nose downwards. For context, the stabilizer, or the horizontal stabilizer, that's the tail of the airplane. The tail has the horizontal stabilizer, which are those two small wings, and the vertical stabilizer, which is the bit pointing upwards.
And the idea is that this would go into effect before the pilot even realized something was going wrong.
Exactly, yeah. Now, as originally designed, MCAS would intervene in a limited manner, as it would only be able to defect the angle of the stabilizer by a maximum of 0.6 degrees, enough to solve the wind-up turn issue, but not enough to cause other issues in the process of doing so. Activation would be determined by data from both the angle of attack sensor and the aircraft's accelerometer. However, further flight testing revealed that the same tendency to go nose up of the MAX could occur during regular low-speed flight. To resolve this, the authority of MCAS was increased to 2.5 degrees. As the maximum nose-down position of the stabilizer is 4.7 degrees from level, this meant that 2 activations of MCAS would be enough to put the airplane in a full nose-down position. Since the accelerometer would not detect this tendency to stall at low speeds, MCAS activation was also simplified down to relying on a single factor, just one of the MAX's 2 angle of attack sensors. It's also important to note that MCAS was not a part of the aircraft's regular autopilot, and it would remain on even with the autopilot disengaged. Basically, this thing is almost always on.
So just to re-summarize, Boeing is using old technology and they need to put out an update relatively fast. While testing, they're like, this thing's great, but there's this tiny little problem where sometimes when they do a very niche wind-up turn thing, there's this little problem. So we're going to put in this little fix, this little system that's going to fix that tiny corner case. Then they test further, and it turns out that the pitch upward problem is way more common than they thought it was going to be. So the MCAS response program needs to be even stronger. The term authority, it means like how drastic things have to get in order for it to go into effect. So basically, the thing is now going into effect more often, and it's doing something more drastic when it is going into effect, correct?
Yes. Yes, exactly.
And this is something we probably have in the notes later. But this whole MCAS system, this is one of, dozens, hundreds of systems and autopilot features in these planes?
Yeah. There's the regular autopilot, auto throttle, auto trim. There's heading hold. There are all sorts of different systems.
Yeah, and this is just one of the many systems that a pilot is dealing with while flying a plane. But again, this is considered a tiny little corner case fix to one of the Boeing's features. So we're talking a lot about this thing, but in summary of the 737 MAX, this MCAS system is considered like a tiny detail, right?
Yes.
So much so that the pilots flying it, most of them don't even know it exists.
Exactly, yeah.
But MCAS is put into place. It seems to fix all the problems they had in testing. And from a sales perspective, the 737 MAX looks like a success. Orders were good, and it looked like the 737 was set for another decade or so of near equal competition with its rival from Airbus. Sales of the MAX were in many ways aided by the fact that it was based on an older plane. This is kind of the old reliable. Boeing told airliners and regulators the MAX was similar enough to the 737 next gen that pilots certified on 737 would not have to retrain to the MAX. Remember, we said this before. The pilots think that the MAX that they're flying is more or less the exact same as the next generation that they might have been flying for, 15 years?
Yeah.
More?
Yeah.
All they would have to do is read some material, and that would be it. MCAS ensured this, to the point where Boeing decided to not even mention the existence of the system in the training materials offered to airlines. We'll get into the crashes in a second, but this to me is like the biggest, most insane thing, right? Like, at the saddest and craziest bit, that the thing that killed these pilots was something they didn't even know about. Like, they never had a chance.
Yeah.
The 737 MAX gained its FAA certification. That's the U.S. government
Federal
office.
Aviation Administration.
Yes, that makes the planes legal.
Yeah.
It gets its certification in March of 2017 and enters commercial service May of that year. Just a little over a year later than its rival, the A320neo. MAXes began taking the skies around the world. And while Airbus had caught Boeing off guard, to most, it now seemed that Boeing had responded effectively. As it turns out, though, the flawed design of the MAX would soon bring about two incidents that would lead to a dramatic reversal of that perception.
We normally write these episodes so that their scripts detail decisions and events in chronological order. But for this episode, I think it's best to describe the two tragic incidents that cost hundreds of people their lives and led to the grounding of the entire 737 MAX fleet before going back and investigating the factors behind those crashes, which is a timeline similar to the investigative process that investigators, journalists, lawyers, and regulators had to engage in themselves.
The first tragedy was Lion Air Flight 610. At 6:20 a.m. local time on the 29th of October 2018, so a little over a year since the MAX went into circulation, Lion Air Flight 610 took off from Jakarta, Indonesia, heading towards Pengkal, Pinang. The aircraft being used was an essentially brand new 737 MAX 8, which had been delivered to the Indonesian airline just 2 months prior. Immediately upon takeoff, the aircraft... Really quick, Jay, is there anything significant about it being a MAX 8? Are most of them MAX 8? Do we just not need to worry about that?
I mean, the ones we'll be talking about today are both MAX 8s.
Does it just mean like the size?
Yes, 8 refers to the size. That's kind of like the middle market one. The MAX 7 is a little bit smaller. The MAX 9 is bigger, and the MAX 10 is the biggest.
So immediately upon takeoff, Flight 610's aircraft stick shaker activated due to a faulty angle of attack sensor, which was indicating a high angle of attack.
Yeah, and just for context, a stick shaker is what it sounds like. It's a device that will literally vibrate loudly the control column of the aircraft to warn the pilot that a stall is oncoming and they need to do something about it.
So if you're the pilot, just imagine you're pulling up on the stick and suddenly the console in your hands just starts jittering around.
Yeah.
Those
and
pilots...
It's loud. Like, stick shakers are like, if you hear one go off, it is scary.
So you cannot ignore this, and it's immediately is going to send panic through them. And the pilots of Flight 610 confirm that the angle of attack sensor reading was inaccurate, and they proceeded to disengage the autopilot and continue to 2,000 feet. So, Jay, correct me if I'm wrong, but essentially they get this big, like, whoa, something's wrong, but they're like, no, everything's fine. And so they take over manually and they keep going.
Yes.
So they're at 2,000 feet, and at this altitude, MCAS, a system they did not know existed, and remember, a system that is not built into the general autopilot, it activates. This is a system that is supposed to push the nose down when the nose gets too high. But remember, this time the craft thinks that the nose is too high, but the nose is fine. So when MCAS pushes the nose downward, it does so pushing it towards the ground as a litany of airspeed, altitude, and stall warnings all sound. And for the next 10 minutes, the pilots battled the system they were unaware even existed, countering the downwards trim by using the electric trim switches on their yokes and pulling the control columns back with full force. An act that on previous versions of the 737, but not the MAX, would automatically disengage any computerized commands on the opposite direction. As confusion, fatigue, and stress took their toll, however, again, they're fighting this thing for 10 minutes, MCAS won the battle for control over the aircraft, and Lion Air 620 plunged into the Java Sea at 6:31 a.m. with a speed of 500 miles per hour, killing all 189 crew and passengers aboard the aircraft.
About 5 months later, on the morning of March 10th, 2019, another 737 MAX 8 took off from Addis Ababa, Ethiopia, heading towards Nairobi, Kenya. This was Ethiopian Airlines Flight 302. Shortly after takeoff, one of the MAX's angle attack sensors registered an almost impossible reading of 74.5 degrees, well beyond the point at which the aircraft would have stalled. Stall is about 20 degrees, so 74 is absurd. As in Lion Air Flight 610, an array of warnings lit up and sounded in the cockpit. Now, here I'll be quoting from an article from Seattle Times. A lot of the research for this episode does come from Seattle Times. They have a series of excellent articles on the MAX. And this is just describing the cockpit experience. Besides the stick shaker, they heard repeated loud "don't sink" warnings that the jet was too close to the ground, a clacker making a very loud clicking sound to signal the jet was going too fast, and multiple warning lights telling the crew that the speed, altitude, and other readings on the instruments were unreliable. So basically the airplane is telling them both that they're stalling and they have to point the nose downwards, and they're too close to the ground, so they have to point the nose upwards.
And all this is happening while loud sounds and lights are just blasting all around them, making it hard to think.
Yeah. The pilots of Flight 302 had the advantage of not being unaware of the MAX's peculiarities as those of Flight 610, as an emergency airworthiness directive had been issued by the FAA after the Lion Air crash. This directive instructed pilots to follow the procedure for what's called a runaway stabilizer trim, which involves cutting off all electric power to the stabilizer. This directive, however, again did not mention MCAS by name. It also merely suggested in a single line that pilots can use their electric trim switches to counteract the nose down trim before cutting off all power to the stabilizer. They thus skipped that suggestion, and you can actually read the flight directive. It's pretty easy to see why they'd be confused. Again, it just says that like you can use the electric trim switches first, and that's like in the lowercase. And then the sentence immediately after that, talking about runaway trim stabilizer, is like all uppercase. So you pretty much just default to that.
Especially while you're having like lights and shit screaming in your ears and like your instincts are taking over and panic's building in the back of your head.
Yeah, because like, you know, these pilots would have been aware of the Lion Air crash. Like they have to have been thinking like, you know, that it is possible that they could have a repeat of that. In order to prevent that, they thus immediately killed the stabilizer movement by doing the, basically just by cutting off all electric power to the stabilizer. The result of this, though, is that the stabilizers remained in a nose-down position, basically frozen, as power was cut to them. And while the pilots were able to keep the aircraft flying kind of level by pulling back on the control column with full force, they found themselves unable to trim the plane manually, as a result of the force of the air rushing over the stabilizer, which meant that the manual trim wheel, that's the way you change the trim manually, simply wouldn't budge. You know, the trim wheel was literally connected by cables to the stabilizer, and the force of the air is just too great to move it. In order to save their aircraft from a system that was still largely unknown, the pilots of Flight 302 decided to turn back power to the trim stabilizers. This decision, however, would prove fatal, as MCAS immediately re-engaged and pushed the nose further down. At 8:43 a.m. local time, Ethiopian Airlines Flight 302 collided with the ground at a speed of over 600 miles per hour. All 157 passengers and crew were lost.
I can only imagine how terrifying that would be. Yeah. So they were fighting this thing for a while, right?
Yeah. And like, yeah, it's like they're in this cockpit, all sorts of alerts and alarms are blaring. When they say like pull back on the control column with full force, this is linked hydraulically to the flight controls, meaning like they're exerting a large amount of actual physical force. This is not like
you got a grown man like putting his full weight and like while his palms are sweating up the console and physically yanking this thing, but it's not helping.
Yeah. And, you know, they are all while doing this, they have to try to diagnose the problem and go through these different checklists to try to resolve it.
You know, while you've got, on top of all of those signals blaring, an entire rest of the crew and passengers freaking out.
Yeah.
The combined death toll of Lion Air Flight 610 and Ethiopian Airlines Flight 302 comes out to a staggering 346 dead. To have two fatal accidents involving two similar failures in a brand new airliner in the 21st century was essentially unheard of, and immediately begs the question as to how and why the 737 MAX was allowed to fly in the first place. The story of the 737 MAX's design and certification process is a textbook example of the disasters that can result from both a decision-making process that prioritizes short-term profits over safety and sound engineering, and a lack of effective government oversight over corporations. How did we get here? For most of their history, Boeing had a reputation of being an engineering-led company. They were, of course, a corporation, but many of their top leaders came through the ranks of Boeing's engineering department. By the late 90s, however, that began to change, especially with the McDonnell Douglas takeover. Boeing's takeover of McDonnell Douglas is often blamed by Boeing employees as the main factor behind a cultural shift in the company. McDonnell Douglas, towards the end of its life, had become known for penny pinching and focusing on aggressive sales tactics. And while Boeing is the company that acquired McDonnell Douglas, much of the McDonnell Douglas more business-oriented middle and upper management would go on to be very powerful within the new Boeing Corporation, and thus it would take on these smaller companies' penny-pinching nature.
Yeah. And, it does seem most likely that the McDonnell Douglas acquisition was just one element in a shift in Boeing corporate culture towards being more finance and engineering oriented. The rush to compete with Airbus led to pressure on the engineers and flight testers that may have prevented them from doing their jobs properly. Again, this is quoting from the Seattle Times, an article titled The Inside Story of MCAS. Two former Boeing test pilots described a culture of pressure inside the company to limit flight testing, which can delay projects at a time when orders are stacking up, costing the company money. Boeing never flight tested the scenario in which a broken angle of attack sensor triggered MCAS on its own, instead relying on simulator analysis, according to a person familiar with the process. One of the former test pilots expressed bewilderment that the angle of attack failure was never explored in the air. A variety of employees have described internal pressures to advance the MAX to completion, as Boeing hurried to catch up with the hot-selling A320 from rival Airbus. Mark Rabin, the engineer who did flight testing work unrelated to the flight controls, said there was always talk about how delays of even one day can cost substantial amounts. Meanwhile, staff were expected to stay in line, Rabin said. It was all about loyalty, Rabin said. I had a manager tell me, don't rock the boat, you don't want to be upsetting executives.
At the end of the day, requiring pilots to undergo simulator training to transition from 737 next generation to the MAX would have not been so huge a cost that it to have doomed the MAX's business model. The executives at Boeing, however, saw no simulator time as being something that would let them make even more money. A nice bullet point on their slideshow presentation as to why you should buy our shiny new MAX. And that's what they made their employees accomplish. Boeing's attitude of putting profit above all else was aided by the deregulation that had taken place in the Federal Aviation Administration. Prior to the 2000s, the FAA appointed designated engineering representatives to work at manufacturers such as Boeing and certify the safety of aircraft under development. In 2005, in part due to congressional lobbying by Boeing, this system was replaced with one based around corporate oversight. We can police ourselves. Manufacturers would select and supervise the safety monitors, and they would report to corporate management instead of the FAA. The FAA kept an office in Seattle to oversee Boeing as a whole, but the employees there were under constant pressure to consider the needs of Boeing's schedule. These are government employees being told to bend themselves to the will of a corporation, to the needs of a corporation. This is to say, they were essentially being asked to help Boeing make money instead of oversee the safety of Boeing's products. Quoting now from ProPublica. According to a veteran FAA engineer in Seattle, there has been constant pressure from FAA managers to delegate oversight of plane development to Boeing. The FAA will tell you we do risk-based resource targeting and that we put resources where there's the most risk, he told me. That's not true. The biggest focus is Boeing's schedule.
Yeah. And a series of internal emails released to Reuters after the crashes reveals a culture of neglect and nihilism at Boeing. In one email from before the two crashes, an employee tells another that he would not put his family on a MAX aircraft. In another, an employee states that the company will go face-to-face with any regulator who tries to require simulator training for MAX pilots. And in a third, an employee stated, I still haven't been forgiven by God for the covering up I did last year. Can't do it one more time. The pearly gates will be closed.
Yeah, that's quite the statement.
Not what you want to hear from people designing airplanes.
Yeah. You know, when I get on this thing that's gonna have me thousands of feet up in the air, I do not want to know that the guy designed this is saying, God is going to damn me for what I did to this bitch.
Yeah.
That is not a vote of confidence. So, we've talked a lot already about the MCAS, and it's easy for, like, the headline of this to be, the MCAS caused these things to crash. But one of the reasons I think this story is fascinating is that it's more of a chain of failures than anything at all. You know, ultimately, the first failure being, like, Boeing failing to update their shit, right? And taking the easy way out of just reiterating on the 737 over and over. The MCAS never would have had to exist if they hadn't solved that problem. And as we've already gone over, the MCAS is a system that existed primarily as an easy solution to the aerodynamic problem inherent in the MAX's design. MCAS, as it was first designed, with a command authority of 0.6 degrees, activated by 2 sensors, was submitted as part of a safety review to the FAA during development. However, when the MCAS was changed, so its authority would be expanded to 2.5 degrees, and the system was redesigned to operate with a single sensor, those changes were never presented to the FAA. Think about that for a second. The thing that caused over 400 people to die, that change, the FAA never reviewed it.
Yeah.
Jay, I don't know about you, but I am quickly moving in a redacted, extra redacted mood when learning about this story and what should happen to the people who caused this problem.
I don't blame you. That was my mood following this story as well.
The decision to tie MCAS to a single sensor itself is highly questionable. So much so that it's been called out by many former Boeing engineers as almost inexplicable. Under Boeing's internal analysis, the chance of an angle of attack sensor failing was low enough to make the system acceptable, and adding a third angle of attack sensor to the airplane would have been expensive. In reality, MAX planes experience sensor failure at a higher than expected rate, possibly due to the external damage. For example, a bird striking the system is suspected to have been behind the failure of the Ethiopian flight. Remember, the MCAS is what caused both of these planes to crash, but in both of those examples, it was a faulty angle of attack sensor that set MCAS off in the first place.
Yeah. In the end, the FAA certified the 737 MAX in large part based on information presented to them by Boeing with very little questioning or oversight. Indeed, the FAA went along with Boeing's desire to keep MCAS out of pilot training manuals. Now, most large aviation safety agencies, different countries have their own, have policies put in place that allows them to fast-track aircraft to be certified in their own airspace based on the decisions of the agency the manufacturer is based in. In other words, when the FAA certified the MAX to fly, their counterparts in the European Union, Canada, Japan, India, China all followed suit, they trusting that the FAA had done their diligence. And, after they did that, most smaller nations quickly did the same.
And this is similar for many regulatory agencies, right? Like, a lot of countries basically outsource their safety to American regulators, which is, maybe not always the best of ideas.
No, maybe not. Boeing's initial response to the crash of Lion Air Flight 610 was to blame it on pilot error, citing that if the pilots had simply followed the procedure for runaway trim stabilizer, they could have averted disaster. Now, I actually remember, a lot of the talk around this crash in forums and even amongst journalists, and one of the things you constantly heard was quote-unquote third world pilots. The idea that these pilots were just...
Ethiopia.
Yeah. like American pilots wouldn't have done this. It would have been fine. So why are you concerned? Now, this
Yeah,
response.
the problem isn't Boeing. The problem is brown people.
Yeah. Yeah. Now, this response ignored the stress on the pilots due to numerous alarms and warnings set off by the angle attack failures, and the fact that the pilots did fully pull back on the control columns, which would have canceled any automatic nose-down commands on previous 737 models.
So these pilots had the experience and the knowledge to do everything to fix this problem on a 737 next generation, which was what they were told they were basically flying.
Yeah, if they were flying an NG, neither of these two instances would have resulted in the crash. The Emergency Airworthiness Directive issued by Boeing and the FAA after the crash also failed to clarify, and I should say this crash refers to the first one, the Lion Air one, failed to clarify the existence of the MCAS system or lay out a clear way of dealing with MCAS activation. The inadequacies of this directive allowed for the second fatal accident, the crash of Ethiopian Airlines Flight 302, to occur just months after it was issued.
That's the amazing thing, right? Is that it happened once, and because it happened in Indonesia, because it probably, took a long time to figure out what was going on, fish the Indonesian plane out of the sea, diagnose things, because Boeing was so well trusted, because so many of these planes were already in service across the country, everyone kind of just assumed it would be fine, maybe a little fix, and then another batch of 100+ people had to die before the problem was fully diagnosed. If a plane had crashed, if that first flight had crashed in Alabama, in Alberta, outside Manchester, do you think that would have happened? Do you think that it would have been it's probably fine? Fuck no, right? Absolutely fucking not.
Yeah.
And perhaps the most remarkable thing to come out of this whole affair is an FAA internal risk analysis that was authorized after the Lion Air crash. This risk analysis from December of 2018 estimated that the flight control failures that had brought down Lion Air 610 would result in about 15 more fatal crashes during the 45-year life of the 737 MAX fleet globally, or roughly 1 every 3 years, a rate of accidents that is unheard of with modern airliners. In spite of this stark projection, the FAA kept this analysis internal and did not ground the MAX, as Boeing assured them that they would resolve this set of issues themselves. Had the MAX been grounded in early 2018, as the FAA regulators knew it should be, the lives of all 157 fathers, mothers, sons, and daughters aboard the Ethiopian flight would have been spared. Even after the crash of Ethiopian Flight 302, Boeing continued to emphasize that pilot and maintenance errors were to blame, blaming Indonesian and Ethiopian pilots and crew for what happened on their planes. To an extent, that's correct. The crews aboard both flights could have, in theory, saved the airplanes. There were actions that could have been taken to make a different outcome. And on Lion Air 610, there were issues with the angle of attack sensor detected, but not addressed prior to takeoff. However, Boeing's defense ultimately rests on the notion that pilots should have responded in a quick and decisive specific manner to a situation that they were not properly trained to deal with, caused by the activation of a system that they did not know existed, all while the cockpit was full of alarms and warning lights. In a sterile, low-risk environment of a simulator, that may be possible. But in actual flight, the chances of human error expand exponentially. Yes, the actions of the pilots or inactions caused the crashes, but it was Boeing's system failing and Boeing's inaccurate estimates of how wrong this would go, and Boeing's failure to order training for the pilots that made those human errors possible. Listen, no manufacturer can design an airplane that's impossible to crash, but they can design one that can deal with human error, something that will inevitably recur in the safest possible manner. The MAX clearly was not designed in such a way, and here we're going to quote again from ProPublica. An airplane shouldn't put itself in a position where the pilots have to act heroically to save the plane, the veteran U.S. commercial airline pilot told me. Pilots shouldn't have to be superhuman. Planes are built to be flown by normal people, Gregory Travis, the pilot and software engineer, said. MCAS sealed their fate. Everything that comes after that is just noise.
On March 11, 2019, the day after the crash of Ethiopian Airlines Flight 302, regulators in China and Indonesia made the decision to ground the 737 MAX. The European Union, India, and several other nations made the same call the following day, all while Boeing CEO Dennis Muilenburg attempted to convince President Trump that the MAX was still safe to fly. Finally, on March 13th, the FAA made the call to ground the plane. By the end of March, all 387 737 MAX around the world had been grounded, essentially banning them from any sort of commercial service. Congress, the NTSB, that's the National Transport Safety Bureau, they're the ones who investigate crashes and stuff like that after they occur. And several foreign regulators launched investigations on the design and certification of the 737 MAX, and new legislation was passed with Congress returning some oversight to the FAA. When the MAX was grounded, many expected it to return to the air within a few weeks or months. Instead, it remained grounded in the US for a total of 20 months, only receiving a new certification in November 2020, the longest grounding period for any US-manufactured airliner. The EU and China have since recertified it to fly as well, but only after conducting their own extensive testing on the changes made to the MCAS system. Speaking of those changes, Boeing was forced into making several changes to the MAX. MCAS would now take information from both angle of attack sensors instead of just one, and not activate if the two disagreed by more than a few degrees. An angle of attack disagreement warning light would be standard on all MAXs, whereas previously it was an optional add-on. And finally, pilots would have to undergo the simulator training on the new systems to be certified to fly the new aircraft. Boeing finally admitted fault for the two crashes in November 2021 in order to settle a lawsuit filed by the families of those who had died on Flight 302. Earlier that year, they agreed to pay $2.5 billion in agreement with the Department of Justice as a result of a charge of conspiracy to defraud the FAA. And Boeing's chief technical pilot, Mark Faulkner, was individually indicted for fraud as part of the ongoing case. In total, the grounding is estimated to have cost Boeing $20 billion in fines, compensation, and legal fees, and $60 billion in canceled orders. Dennis Muilenburg lost his job as CEO. However, he and the rest of Boeing's top executives, as well as FAA's top managers, remain unpunished for their decisions. Really, looking at, these cases, Mark Faulkner, the pilot, was involved in these decisions and should have charges brought up against him, most likely. But I think it's pretty clear that he's a bit of the fall guy. He's the guy who was high up enough that Boeing could offer him up to the government as a scapegoat, essentially. But he wasn't the CEO. He wasn't a top exec. He wasn't really making these decisions. And the people who were, probably nothing will ever happen to them.
What fascinates me about this story is the chain of events that caused these crashes. MCAS forced these planes down, but MCAS was only in place because Boeing had encountered problems in their testing. Problems that only occurred when Boeing attempted to force their decades-old plane to stay in the air. And Boeing made the decisions they made because they were being berated by their shareholders and executives to get a profitable plane in the skies as soon as possible. And they only got away with it because the US government outsourced the safety of these planes to the people making them because the congressmen that run the country had been sufficiently bribed by Boeing itself. Flight 610 and Flight 302 didn't crash because the pilots weren't smart or courageous enough to save the plane. They crashed because a system that made trillions of dollars over half a century of economic dominance, a system that thought it was invincible, failed. A system that got 346 people killed. Because no one is competent. And that is going to do it for episode 16. The next episode will be out in 2 weeks' time as we resume our broadcast. Jay, that was I don't know if I've been this pissed off like since. No, I think I'm more pissed off at this one than the invasion of Iraq episode. Sorry, Afghanistan. Since the invasion of Afghanistan episode. When we did our Chinese Great Leap Forward episode, that was so exceptionally bleak. And that involved, obviously, 30 million people dying instead of 300 plus. But it's a similar situation that gets my blood boiling because it's like a few individuals make a choice, assuming it's going to be fine, assuming that they know better, and it results with unrelated people dying. And
yeah, and it's not even not that things are better, obviously, in the name of ideology or whatever. Horrendous decisions have been made in the names of such things, but it's just really banal, when these decisions are made, not just to make money, but to make a little bit more money.
Yeah, and
versus, something that's
this
coming out of an actual worldview or a foreign policy position or something like that, which may be wrong, but is maybe a bit more respectable.
Well, the thing is that Boeing and the FAA people trying to get this plane in the air, they probably made dozens, hundreds of decisions just like this that were fine, that turned out fine. And so things slipped just a little bit more. Sure, we can turn off just a little bit more profit. Oh, surely the guys at Boeing have done this so many times that, we can trust them when they say that this is safe. And it just slips just a little bit more, just a little bit more, just a little bit more, until hundreds of people die. And then even then, you are so pompous, you are so arrogant, you are so fucking bribed that you let it happen again. There's a part of me that wants to laugh because it's a farce, but I'm just fucking, oh God, I am going to have to bleep all of that, aren't I?
Yeah. Probably.
Yeah. First ever no one is competent bleep, baby. All right. Jay, two things occur to me. Thing number one is we didn't have any plugs at the beginning of the podcast. So,
I can do them now.
We will do them now. Everyone should go follow us on Twitter at not_competent. Email us at nooneiscompetent@gmail.com. We would also heavily appreciate, I've been recording for 2 hours, if y'all would go rate us on the Apple podcasting app and like and subscribe to our YouTube channel. Again, YouTube is a great place for finding diagrams if you want to see what these plane crashes looked like, or be able to visualize a little more all the forces we were talking about at the beginning of the episode. Jay, anything you want the people to know about?
Our music is done by Sam Bryce, and you can follow us both individually on Twitter and YouTube. My Twitter username is @Jaharius48. I'm the same on YouTube, and I believe you can be found on Twitter @Azalea Wyatt, and on YouTube as Wyatt the
No,
Word
I
Weaver.
do not have a YouTube channel. There's no YouTubes associated with me. I don't know. Jay's been opped by the CIA. I don't know what he's talking about. Yeah, that's gonna do it for this one. First bleep, gonna have to figure out how to do that in Sony Vegas, which is where I edit these motherfuckers. Damn, this is supposed to be an entertainment podcast, and now I've just depressed everyone.
Well, I mean, the world's already doing a good job of that, so,
Manifest happiness! Manifest happiness! Manifest happiness, everybody! Have a good night! Well, no one is competent. Signing off.